like to just start off by getting some things out of the way, such as I just started. So I'm still learning quite a bit. However, I have focused on this particular topic so I can give a good presentation around this topic. But if you're looking for advanced Redis conversation, I'm just not going to be able to do that today. However, maybe someday in the future. A couple other things is Redis Labs and Redis are not the same. Redis Labs is a company separate from the open source project. It does not own the open source project. So I just want to make sure that's very clear. And finally, this is just a talk about open source Redis, although I might mention our company and other companies once in a while, but it's not a pitch or promotion of Redis Labs. So we're going to talk, everything I say here is about open source Redis. I do have t-shirts, so if you stick around towards the end, I can give you a couple. Well, one each, but I got one for all of you if you want one. Also, I took a lot of the content for this talk from a book called Redis in Action by Josiah Carlson. That's right. And I met him down in Los Angeles not too long ago. Super bright guy. If you ever want, the book is actually mostly free online at redislabs.com/academy, so you can go read it there. He's got a PhD. He's wickedly smart. Does not work for Redis Labs, just happens to have partnered with us to promote this book. So let's go ahead and get started. Now, what I want to do is to give you an idea about what Redis is, and we'll give you some use cases. That's the primary focus of this talk. I don't know if we'll go the full time, but we'll see how long it goes. So first of all, what is Redis? Redis is an open source in-memory NoSQL database. It was created roughly around 2009 by a guy named Salvatore Sanfilippo. He's out of Italy. And he's done amazing work, but he's not the only one. He's also got a crew of folks who work with him in the open source community. He did just recently join Redis Labs. So, it's obviously a vote of confidence for us, but he's still working on open source Redis. So he's not actively working on our products or anything like that. Redis is known for being wickedly fast. It is a very, very fast in-memory database, and that's what most people think of it as, being very, very fast cache, and it's also a database, so it's both of those things. So what can you do with Redis? So again, like I said, a lot of people think of it as a cache. That means you might already have a database like MongoDB or SQL Server or MySQL or something like that, and there's certain parts of your website or your application that need to get at that data more quicker than your database is able to respond, and so you might put some of that data in memory as a cache. So Redis is used primarily in that way. But it's not just a cache where you take and put strings. Oh, it's also a cache. That's kind of funny. Flip over here. Okay, it's also a cache where you can put data structures. So it has strings, lists, sets, sorted sets, and hashes, plus some additional data types like a bitmap and a hyperlog log, which we will talk about a little bit further. It has 160 commands too, so sometimes you need to make a transaction or something. Well, there's a whole bunch of custom, specialized commands that you can do with Redis, where it's created. These commands are created specifically to be high performant. So instead of writing your code that gets the data, brings it back, does something, and then sends the data back to Redis, you send the data in a function call, and it does all of the work on the server very, very fast. If you need to do something custom, where you want something to be done very, very fast on the server, you can use Lua scripts. Lua scripts are it's its own programming language, but it compiles into memory, so you're not leaving Redis to go do the work. It's actually all done in memory on the same server. And there's lots of different use cases. I'm going to go through some of these use cases, but you can store your sessions in Redis. You can keep a list of most recent visitors. You can compare which one of your friends are my friends. You can do pub sub. There's lots and lots of examples. So who uses Redis? Tons of companies. All these companies that you know of, they all use Redis. It's incredibly fast, and if you have lots of people hitting your website, You can cache that data, but if you want to do something that's interactive or something where they're getting the most recent, let's say, posts to a website, like what Twitter does, that needs to be done more in a structured way, and Redis is perfect for that. So Instagram, Pinterest, Tumblr, Craigslist, Stack Overflow, GitHub, even Docker uses it to host all that data about their Docker images up on Docker Hub. I just heard a funny joke. The most difficult engineering job in the world is the engineers at Stack Overflow, because when Stack Overflow goes down, they can't use Stack Overflow to troubleshoot the problem. All right, who contributes to Redis? A whole bunch of people, but it's primarily Salvatore. However, there are a long tail of folks out there who contribute. You can see this is just a kind of a chart of contributions over time, so it's been fairly consistent and growing a little bit over time. But the product's very mature now, so they're adding functionality, but I think it's only if it feels like they're only adding things that are going to help make it faster, or some edge cases, but the primary functionality seems to be there. So where can you get Redis? So you can go get it from the open source download off of GitHub. There's also redis.io. It's a great resource for Redis if you're looking to get started. There's a lot of material there, documentation at redis.io. If you want enterprise cluster, Redis Labs, the company I work for, offers that. You get a free download. You can also use Redis Cloud, also by our company. This is Redis as a service up on Amazon, on Azure, on Google, on IBM's clouds. So we run it in all of those clouds. And there's lots of other companies out there. So you can go to Redis Green, Open Redis, again, Redis Cloud, and Redis to Go. These are all different Redis as a service providers. Even Amazon Elasticache is based on Redis. So, and Azure's Cache is also based on Redis. So Redis is very, very popular. So again, let's go into some details here. So, what is Redis? So very specifically, some people, you've probably heard the term key value store. So Redis isn't really a traditional key value where the value is a string. It's what we call a key data structures server or store. And what that means is it has more than just string values that get stored in cache. It can store data that's more like a database. And there's different types of data values. So you can have strings, lists, sets, sorted sets, and hashes. A hash is kind of like a hash table. So that's very similar to a table. You can also have bitmaps in memory, and there's something called a hyperlog log, which I'll talk about briefly. It's kind of a new thing. It runs in memory, as I said before, which means it's extremely fast, both for reads and writes. And it does have disk persistence, so you can have a log and you can capture the data so that you're storing it on disk, and therefore, if something were to happen and it goes down, you can survive the crash. It'll load back up for you. And because it only runs in memory, your limitation primarily is the memory available on that particular server. You can cluster Redis. You can do it with the open source version. However, if you need help, or if you feel like you just rather have somebody provide you the technology that does all that, that's what our company does. But let's move on to how Redis is used. So it's, like I said, it's extremely easy to use. It's very well documented up on redis.io. So go take a look. There's lots of good, useful information there. Most people use it as a cache or as a second database. So if you've got a database on your server that's saving your data on disk, but you are having problems scaling that, you can use Redis not only to cache, but also to keep the data from the database in memory so you can query it. And some folks actually do use it, capture the data so that you're storing it on disk, and therefore if something were to happen, it goes down, you can survive the crash. It'll load back up for you. And because it only runs in memory, your limitation primarily is the memory available on that particular server. You can cluster Redis. You can do it with the open source version. However, if you need help, or if you feel like you just rather have somebody provide you the technology that does all that, that's what our company does. But let's move on to how Redis is used. So it's, like I said, it's extremely easy to use. It's very well documented up on redis.io. So, go take a look. There's lots of good, useful information there. Most people use it as a cache or as a second database. So if you've got a database on your server that's saving your data on disk, but you are having problems scaling that, you can use Redis not only to cache, but also to keep the data from the database in memory so you can query it. And some folks actually do use it as a first-class database. In other words, they don't have another database. This is their only database. Usually you might do that if the data that you're keeping in your database isn't very useful after a short period of time. Like, for example, in high-frequency trading or something like that, where all the data is really happening in real time, and maybe you stream it off and store it somewhere as a log, but you don't really need to keep that data. If it were to go down, it wouldn't be useful to bring it back up because time has already passed. So who is using Redis? There's a lot of different companies I mentioned before. You can go take a look at this URL and see tons of companies using it. And by the way, I forgot to mention, it's also great for other things like PubSub. A lot of folks use it for PubSub. So what that means is you have a lot of web browsers open and they're all viewing a shared set of data. Then you can have them subscribe to Redis, which will then let them know when a change occurs, and they can all update their browsers simultaneously. I've actually written an application using Node.js for that. And there's a configuration file that you set up. It's really simple, so it's actually quite simple to set up individually. It's also single-threaded. This is kind of interesting. So what that means is it's only doing one action at a time. So it queues them all up, and it does them all in a row. This actually helps with performance because you don't have to worry about a record being locked. It's just doing one action after another. There is no locking because of that. So, and it's so lightning fast that it actually is quite hard to give it so many requests that it can't handle the load, although you can, that can't happen. So it's incredibly fast, and the single-threaded actually helps with that. What this means, though, is you tend to shard. If you run out of memory, you need more space, you tend to shard your database, so you might have transactions A through F on this database, on this server, G through M on this server, and N through Z on another server. So that might be typically how you were to scale. And okay, so I mentioned earlier, or maybe I didn't, but anyway, it's often compared to Memcached. Redis actually supports Memcached for the most part, so a lot of folks actually have used Memcached, might switch over to Redis because they get the Memcached functionality plus the Redis functionality, and it's just as fast as Memcached in most cases. And again, you get this rich set of data, not just key value pairs. You get to store data in a structure, so you can do querying in memory. And it does support persistence. So, if your server goes down, you don't have to. Your server might have to come back up, or you can recover from another server. But you can recover all the memory at once. You don't have to wait for it to rebuild, which can be very slow and painful. And it does replication through a master-slave concept. So you can have a set of your data in memory on one server. It can keep a copy in another server. That means if your primary server were to go down, it can immediately switch over to use the copy, and then therefore you don't have any downtime. And in a very common scenario, you would actually have a master-slave scenario where the master is doing all the interacting with your applications, and the slave is actually doing the saving to disk, so they both have their role, and you can perform better that way. So what are some more use cases? Oops, somehow we lost, there we go, okay. That's funny. So what are some use cases? One example is you might show the last items listed on a website, on your webpage, eBay postings or listings, something like that. Obviously, at some point you need to remove them, so you'd have deleting or filtering based on certain criteria. You can do that too. That would be hard to do in a cache where there's no idea of individual records that are in a set. A leaderboard actually makes a lot of sense with Redis. So you might have a bunch of users all competing, And then based on criteria, you could very quickly and easily filter that data and show, the top players of all time, top players this month, top players today, top players right now. All of that could be in memory and sorted quickly and displayed in real time. Also, user voting. You can use a sorted set, which I'll talk about in a little bit, where you can let people vote, and then you've got your names of people or ideas or products or whatever you're voting on, and then your votes. That can all be kept in memory in real time. And you can expire items. So, for example, this is great for things where you know that you don't want that information to display after a certain period of time. You can set an expiration date on the record, and then it will automatically, you don't have to go back and remove it. It will automatically remove itself from the list and therefore automatically stop displaying on the web page at that time. So a lot of very useful functions. Now I've got more for you. Counting stuff, that's probably pretty easy to do. Unique items. So they've got some functionality where you can say, add this to the list, but only if it doesn't exist on the list already. And you don't have to worry about writing that functionality. Redis just does that for you. So that way you can keep it unique without any effort. You can do real-time analysis for what's going on. So if you want to add any information like maybe you're keeping track of bugs from an API. So as an API comes in, every time there's a error message or actually all responses, you can just log them all in memory, and then in real time you're keeping track of all of that activity, and it's all quickly available from your dashboard to see what are the top error messages, that kind of thing. So like I said, you can use it for PubSub. It's also great for queues. There's functionality where you can pass in make a request using a function that says remove an item from this queue and put it in this queue, and it will do them effectively in a transaction, because again, it's all serial, so it'll do that all in one action, and therefore you know that information will get moved from one queue to the other without losing data. So a lot of high performance operations like that. And like I said before, caching. Caching is like extremely popular with Redis. And but I don't want you to think of it as just a cache, but it is a very, very good cache. So the key takeaway from looking at these particular use cases is that with high speed data where you're trying to keep your website responding to really unusual usage patterns that your database wasn't really designed for, rather than trying to model something very cleverly so that you can take your model and mirror it on the website and keep updating your model to match the performance required, the best probable scenario is just simply take the data, keep it the way it's stored, the way you need it to be stored in your own system, but then remodel it using something like Redis and just put it in a way that's going to perform better for your website. And you can take in each individual use case and customize it for that particular scenario so that it performs quickly, and don't worry about changing your own model. You can combine these functions together to get what you need, and because it does the work for you, you don't have to write your own code, which is most likely not going to be as fast. So instead you can call the function, have all the work done on the server, and then you're done, rather than getting the data, pulling it back, doing the work you need to be done, and then resubmitting it to the database. That's not likely to be as fast. So there's a bunch of data types. I don't have a
we need more pressure up front from the Jade.
I'm going to go through some data types for you, and then we'll be done. So let's just take a quick look. You got your string. Okay, it's more or less what you think it might be. You can store a lot, up to 512 megabytes in one string. And it's ideal for all sorts of things. You can do JSON. You can store your data as JSON in a string, just like you would MongoDB or something like that. You can store little bits of data for real-time metrics, or like I said, like active users. You might just store that in a string and just keep that in string instead of a table. You can store binary files, so if you're actually serving images, you can keep that in memory as well. Here's some examples of some functions. And the use cases, you know, like you can do a lot of stuff with this. For example, you can actually tell a record that you want it to not change, like set that value, and it can't change, nothing can change it, and then after a period of time it will either automatically delete or then become changeable. Again, you can use it for a cache. You can put up images, and then you can have you can actually write over the image, you know, put words or something like that over that image, and that let users download that data without having to save it down to disk. So that can be very quick. You can use it for just simple things like A/B testing, and so that it's not you know, you're not having to save a bunch of data. You just kind of look at who's coming in, figure out, oh, it's this session, we'll do this test. So keep some flags in memory, that kind of thing. Lots of different use cases where you just don't need to go put all this in your database. Lists. So these are just internally maintained as linked lists. They're extremely fast, especially towards the beginning and the end of the list. You can have very long lists, and you can use this again for like queues or just stacks of data, top end, recent news, that kind of thing. This is what a lot of folks use for social networks. So this is what, you know, Twitter uses. You know, pretty much all those social websites are using this functionality. And used for logging users' actions. This rpop push is what I talked about earlier, where you can kind of take an item out of a queue and stick it in another queue all in one function. We also have sets. Sets is just simply a unique list. So you throw some data in there. If it's already in there, it just ignores it, doesn't add it again. Or you can use sets to compare one set with another set. So your friends with my friends, we can very quickly figure out which friends we have in common. You can find out, you know, hey, here's does this number already exist? That kind of thing. Lots of very simple but very highly effective and fast functionality. Again, it's great for storing social data. Here's some functions. Oops, that kind of got whacked out. So you've got some tracking IP, unique IPs to your website. So if, for example, if you're trying to defend against a DDoS or something like that, you can use this functionality to say, you know what, I've got too many requests from this website in a short period of time. You can set the automatically expire so that you can set it off at, you know, 10 seconds or something like that. And if the person keeps coming back more than 2 or 3 times per 10 seconds, you might decide that that's something unusual. You know, used in tagging information, creating random numbers so you can respond for ads or lottery information, tips of the day, that kind of stuff. That's all great for in-memory. Try that page a little off. You can assorted set. Assorted set's kind of interesting because you can add a value to the number or a value to the data. So this is how you would keep track of, like if people are voting and you have a value next to the list of data, and therefore you can have a sorted list essentially, or sorted set. And basically this behaves just like sets, except you have that value next to it, and it's still extremely fast. And the queries are very fast because the sorting happens immediately upon insert, so the queries are always going against static data. It's very fast. And again, for using examples like a leaderboard, top lists of anything, you can index other data. So if you have hash tables or other lists, you can index them using a sorted set that references off to another structured type. You can, like for example, querying for a range of users.
Well, if Jamila is not going in, somebody have to go in.
Date or age or some other characteristic. And finally, of the 5 main types, you got the hash. And hash is kind of like a table, very similar to a table. And so you've got the value, like a unique user ID, and then you got all the additional values that are stored along with it. You can kind of nest one hash within another, but then that's about as far as you can go. And you can refer to each one of the values individually, and you can even sort them, so it can behave more or less like a regular table. This is where you would store data if you're storing data for example, in a business object, for example, like maybe a person and their characteristics, or an automobile and its characteristics. You can store all that in a hash, and you can keep track of many-to-many mappings that way. And there's a couple bonus types. There's bitmaps and hyperlog. So as I mentioned earlier, you can store images in memory and then manipulate them in memory, and there are operations specifically for that, like bitop, where you can take a particular range of pixels within a range and update them or edit them. And like I said before, you can use this for putting text over an image, all doing that in memory, and then not having to save that to disk because you may not need to do that. It might just be on the fly. And then the hyperlog is kind of interesting. It is what they call a probabilistic cardinality estimator. It's a mouthful. What that really means is you can count a value within a larger string or sets of strings statistically. So you've got, perhaps millions of web pages all with data on it, and you want to know how many times does a particular word show up in those millions of web pages. Well, rather than keeping all that data in memory, what happens is you can iterate through all the data, and then the hyperlog will estimate, will keep a track of an estimate of how many times the words show up, so that you're not having to keep everything in memory in order to find that out. This would be very useful, for example, when you do a search on Google and you were to do a search for Redis, it would tell you how many times Redis shows up on web pages. It's not actually doing an accurate count of that in real time. It's getting an estimate. So it's similar to that. So I'm going to start wrapping things up here. I've got this, like I said, there's a lot of information that I got. It's from the book Redis in Action. You can go check it out at redislabs.com/ I kind of spelled that wrong, but Academy. And then also a couple other things just to mention. I'll be back up here in just a few weeks for something called Container Day, which is actually happening at night in Seattle. So if you're interested, I can also get you 30% off the LinuxCon conference that's going on. So if you're into Linux or anything like that, you can go to the conference for 30% off. But the event I'm putting on is free, and you can go check it out. It's August 16th, downtown Seattle. You can find out more at the Twitter handle Container Day. And that's about it. So I can take questions. I also have some shirts, and I think that's about it. So yeah, that's it. So if you have any questions, like I said, I'm fairly new, but I can get some answers if I don't know the answers. So why don't we start with you in the back?
3, 2, 1, fight!
Yes, you can. Now, like for example, on Amazon or Azure, where you have availability zones, those are probably close enough where something where the time
where did she come from?
Is reasonable. But like cross-continent or around the world replication would be potentially problematic depending on how fast you're updating the data. But yes, you can do that. Yeah, actually there is an open source version. It's fairly new, but if you go to download Redis 3.0, whatever the most recent 3-point version is, it does have clustering in there, so you can try that, and it's the open source version, and then and then Redis Labs provides a supported version that's more based on proprietary clustering that we've created. It is not the same as the open source version. Yeah.
Enemy team won the orb.
Yeah, typically what will happen, and again, Well, okay, typically what will happen is you would set up Redis so that you're installing multiple Redis
Like,
databases.
we didn't
one
even get
from
into the
one,
middle of the map.
and
We
then you
just
would
started
basically
dying.
shard across that. That's how you would handle that. Okay.
Round lost.
I understand it.
So that's a good question that I haven't looked up myself, so I don't know. I do know that somebody said that it would be a good topic for a webinar or a talk to talk about how to do that with Redis. So I'm pretty sure, based on the fact that he was proposing it, that you can do it. I'm not exactly sure the best way to do that. There's a hand back up here. Yeah. Okay, so is there any concern of network blocking? I didn't hear the second part of that.
Enemy team claimed the orb.
Motherfucker.
Okay, so let me try to understand your question. So with the
Oh my
network
god.
actually end up becoming the blocking.
How did he know my
of
destiny
the
was ass?
Yeah, so this is not an area of my strength, but Redis does support
Do not blitz
pipelining
in the pond.
of network calls to the Redis server. So what that means is in the client that you use, if you want to use a client to talk to Redis, the server, it can actually queue up the requests and then send them to the server to get the data back. And it does it in a way that actually speeds up the overall transactions or the operations.
2, 1.
I honestly don't know a whole lot. I know what's going on there. Basically,
Let's get it.
what's happening is you've got so many requests coming in. The database may actually be fast enough to handle those requests, but the network may not be able to handle those requests. So in that particular case, you can help the network out by saying, well, rather than sending one over at a time, let's queue them up and we'll send over 10 at a time, for example. And then Redis is so fast that it can easily handle the 10 and respond and faster than it would have taken to send over 10 over individually. So that's how Redis would handle that, and I believe it actually does a good job of solving that problem. Yes. Yes. So,
Your team won the orb.
I actually don't know very much about how
Mother.
open source Redis does that.
Okay, I tried in that round.
I haven't studied that part of it yet. So I can only tell you how Redis Labs would do that. I'll keep it short. Essentially what happens is Redis Labs would do two things. Number one, it would use up all of the memory for that physical server, except if it determines that it would have better performance by using multiple cores on that physical server.
Let's do another
then it
round
would do
with
that.
Destiny.
It would split up
She's
the
a really good character.
memory to multiple cores based on performance.
I might actually
It would
stop
automatically
using
shard
Jade and
for
start
you.
using Destiny.
Okay, so it would automatically figure
'Cause
that
that
out. You
shield
don't have
thing.
to figure that out, like
Hold up.
which data to put on which.
Jade does give
server.
shields too.
Does that answer your question? Okay. Yeah.
Interesting.
All right. I can't go. Yeah, it's in the back
I
there.
still like Destiny though, because she got like a ton of utility skills and stuff. Like she got an iframe. She got dang.
So the best way I can answer that question is that you can install a client on each one of your servers, your application servers, that can maintain a hash of where the data is actually stored. so that the data, the requests are not going through a proxy and then to the node that has the data on it. Instead, the web application can connect directly to the node that has the data on it, and therefore there's a no shared anything, a shared nothing architecture, and therefore it should scale fairly linear. Does that make any sense?
Hello and welcome. My name is Ryan Lukey, and my pronouns are he, him. I've worked at Box for the past 7 years as a software engineer in application security, accelerated uploads, caching and database.
And my
Most
pronouns.
recently, I've been working on Box Graph.
What have we become,
Today, I'd like to
guys?
share our journey to Redis.
What have this
First, from
universe
Memcached to
become?
Redis, then from
Now you
Redis
have to like
Redis cluster.
introduce your own pronoun
And then
and
I'd like
stuff.
to share some of the things that we've built using Redis.
2, 1.
Finally, I'd like to end with operational learnings. And as part of the case studies, I'd like to showcase a few things we built, like our session store, from store to store to store, and recent files as a feature we've built, chunked uploads that uses Redis in a particular way, and finally our rate limiter service.
You can't fight Jay in a corner like that.
But first, what is Box? Box allows people to securely and easily share and collaborate content from anywhere on any device. It's used by
Motto.
people across 82,000 organizations worldwide. And these are in virtually every industry in the world, ranging from finance to legal to
You gotta
manufacturing,
attack them.
health.
Enemy team claimed the orb.
And so there are a lot of really critical
You gotta attack them too,
companies
Lucy.
have they use Box for.
No,
To
I'm
talk
too
about how we
afraid
get to that kind
of
of
Jade.
scale, let's dive into the technology. Before Redis, there was Memcached in use as a session store at Box. So let's say a user comes to our site, they log in, we hand them back a session token, which is stored in their cookie jar in their browser, and we associate with that token their session information in Memcached. So in this example, we have, say, 4 Memcached servers, and their session lives on the third one. What is wrong with this picture? What's wrong with this architecture? If the third server goes down, that user is logged out. So this is a spot, a single point of failure.
Oh shoot,
So what
she
do?
got her.
We created a secondary tier
Duh.
so that any writes that went to this data store would be written both to the primary tier and to the secondary tier. So
That
now
was
we have the data
crazy.
in 2 places. So if there is a single point of failure, or a single node goes down, then we're able to mitigate that failure. The way it works is we write to both. When we read from the primary. If the primary, we have a miss or it's unavailable, we go and look in the secondary. So this is great from a single node failure point of view.
Hi, my name is Drew Slattery. I'm here to talk to you about Redis.
3.
So
2,
most of us are
1.
fledgling developers, and we've only ever worked with SQL databases for our relational database state management system, specifically Postgres. So while SQL is great, and for a lot of what we've done so far, it really works and it suits the job, we sometimes will run into the problem where SQL isn't the perfect fit for what we're doing. If you're familiar with the concept of Maslow's hammer, it's like a saying that basically goes, when the only tool you have is a hammer, everything begins to look like a nail. So Redis is a solution to some of those problems.
Motherfucker.
So I'm going to give you a brief introduction on what Redis is, so how it compares to SQL, and some of the idiosyncrasies specific to persistence in Redis, which is not necessarily its biggest draw. So first of all, the question we're all asking is, what is Redis? Redis is a NoSQL
Save me.
database, meaning it doesn't use the
Oh.
structured query language you've come to know and love. It's a key value data store, so unlike Postgres,
Save me, baby.
table-based, or
Aww.
another NoSQL
Yo, I
database
knew you had some
that
heal in
is
there.
a wide column, data
I know you
store.
have some heals in there. You just want to
Values, which
1v2.
JavaScript developers are really our bread and butter. And it has a whole
Hold on, we
ton
got a
of
match?
benefits to
Oh,
using a key
damn.
value data store.
Neil got a match.
It is also completely in memory,
Who's our
which
leader?
is really interesting. Being in memory allows Redis to be incredibly
Oh damn,
performant
they already
and fast
picked.
which is most people's main
Shoot.
reason they are interested in it.
Raygun East mode. We got
The interesting thing about
Raygun
Redis
Pearl.
is that it does allow
I bet I'm on
persistence,
it, Pearl.
even though it is in memory, and I'll get into how
Alright,
persistence
after
works
this
in
match,
Redis
well,
in a bit.
I think I'm a bit
Redis is
too
also
late
a data
anyways.
structure server. It gives you several different
Oof, I gotta
data
throw this
structures that
match
you
as
can use,
fast as
so
I
your key
can.
values aren't just big strings that are
Yo, that's
totally
bad.
unorganized. So some of the
I'm a bad dude.
structures that it gives you are binary shape
I'm
string,
about to toss this match
which are
as
just
like
a string, lists, which are a lot like the lists that we've implemented so
a
far,
dog tossing away
sets and sorted sets. And if you don't know
a
anything
sweet bone.
about math, basically you can think of a set a lot like an array where it's a grouping of values, but
A set
the
like an
difference
array.
in sets is that no value will repeat and the order doesn't matter.
God
Sorted
damn.
set, the order does matter.
Oh shit, the
Hashes,
match is starting
we know
now.
very
Fuck.
well.
Alright,
Bitmaps,
I'm a really.
and hyperlog logs, which
No.
sound very complicated.
This is do or die situation right
They
here.
are a probabilistic data structure, which you would use for cardinality of sets, which if you don't speak math, means counting. Redis is completely open source as well. You can look at the docs, and it's very, very well documented. So why would you use Redis? The main reason you use Redis is because it's so darn fast. Both being in memory and a key value store,
Come on.
Redis is super
Oh,
fast.
never mind. He actually did it for me. Okay, guys.
You know
Nail
that
match.
most
Gotta go.
operations are one time complexity. Compare that to a table database where you're looking through each line of the table. It's a pretty big deal. Adding the fact that Redis is in memory just ups that up about like a million times. Redis is also not
Okay,
CPU
let's do this.
intensive, which is really cool. A lot of times when you are doing something super, super complex with a super huge data set, like say Twitter's
Can I be on the
timeline,
Alicia,
that's
bro?
implementation of Redis you can think of.
Yeah, if I ever get shackled with only like with no space and only
Can
parry,
I
that's
be on the Alicia?
Scrolling down the timeline, you're going to want to make lots of little calls.
Can I play the Alicia?
Do you want to play Alicia? Sure.
Okay, let's do this. Thanks. Let's do this.
I'll play Alicia. I got a sick of Alicia.
And that's really something you want to
Ready up.
Hey, Kina, ready up.
Oh yeah, I forgot. Makes
Oh,
no
good.
sense.
Yeah, you shouldn't have to ready up as observer, but I think it's a tournament thing.
Wait, hold
got
on.
it.
You got a
Hold up.
little.
It's a
leak there,
tournament?
buddy.
Senpai,
Oh,
go for
shoot.
Pearl. I'm gonna play Alicia.
Yeah, I'm gonna play Pro.
Just
I got a Pearl.
Yeah, you gotta
before.
listen to the draft captain, unfortunately.
Or it's
Here's
fine. Like
fucking
I
If
was,
you don't like your draft captain, just
I
throw
was
the
in a
game
casual match. I ain't even see what happened.
Are you good?
Hold up, this a Tony?
Nah.
No, or
So
yo,
who
I was
uses
gonna be
Redis?
like,
Twitter, Pinterest, Stack Overflow, Tumblr,
yeah,
and
bro.
GitHub all use Redis, just to name a few. All companies mostly use Redis.
Ready up,
as a
Alicia.
cache,
Yeah.
They will use their storage they'll use a different database for their storage, just because
GMS, turn your TV off.
huge amounts of data.
We're turning down like I hear.
I'm watching YouTube,
Cache is probably the most common use.
trying to
How
get
come
my
I'm paying for your
database.
headset right now? That's my real question.
Well, thanks. Which backline do you think is harder
you
for
gotta-
Raygun?
You don't got a headset? The hell?
Right?
Alright, let thinks. Which one do you think's harder?
What? We're right.
Hi there, Twinkle Toes.
Alright, I believe in y'all.
Dude, I do better into my team.
believe in you, Raygun.
Alicia Pearl. I do way
Was it
worse.
even that bad for right
No, dude, I do good into like it's so easy to swap targets in that backline. Like you just swap, like Alicia shields one person, you just M2 the other one with M2 range. It's so easy.
Mm-hmm.
But I mean, if I'm gonna get like snared and shit in this, so that's gonna be cancer. But good thing I have acrobatics.
Acrobatics is that shit, bruh.
Yep, I'm an acrobatics player. Hate to see it.
Love to see it. What?
Love to see it. Love to see it. Sorry. My Raygun build is actually like a few evolutions above everyone else. You guys will be there eventually.
Let's evolve a step.
Yeah.
Freeze for me.
The only one that like I don't know. I think the snare is good, but like there's just nothing I'd rather take over it.
I mean, it just helps you for true damage.
Now,
You start off with
Yeah,
28
literally, like-
landed.
three,
Like it's just guaranteed value always.
What? Rush
M2
you.
snare.
Asma?
Yeah, I just nobody saw that. Yo, you gotta go in there. You gotta go in there. He gonna take a shitload of damage. Oh, look at that.
Enemy team lost the orb.
Oh, but
Oh,
somebody saved me from Ismo. Oh,
I got you. I got you.
fuck. Oh,
Get the
shit.
jump.
Ooh. Okay.
I'm gonna die.
Oh, bruh.
You
we have
it's
ice
my
block?
highlight.
Enemy
Or no, I
team
could have
won
called
the
for it.
orb.
My oops. Because I was gonna die from the path of the dot.
The death vortex
Destruction. Low Ismo, dude. It's annoying.
Yeah, he was asleep most of the fight. I put him in Nosco freeze on him. Actually, he opened up with a terrible opening.
I think I went a little bit too hard.
Yeah.
Because we almost recovered.
Yeah.
Galante should have been dead in the first like 30 seconds. They should have been pressing to save him. Just saying.
I went to finishing mode and then I got turned on.
That's all
Alright,
good.
we got this.
Oh, the alt right? Is that good?
2, 1, fight.
Longer freeze. Gives you a lot more setup time, or I can just leave people out of the fight. Not like so.
Yeah, you gotta stop. Oh damn! I thought it was Jade. I was like, gotta start
Team won
sniping.
the orb.
Yo, I'm used to Jade picks.
Gotta help out Luke.
Ooh,
I don't even know how I lost my HP. That's so unfortunate.
Older damage.
give him shoe, give him shoe. But oof.
Aw, I fucking hit that. My bad.
Damn, I'm out of use.
You might have played it slower. And Senpai wasn't even able to heal you. You were so far away from him.
I'm dead anyways.
I mean, I just like go in and die.
Yeah.
In like one rotation, it feels like.
Round lost.
Hey, we should let them come in.
I'd probably rather play it neutral. Because they putting a lot of focus on you.
I don't like that. But I'm trying.
No melee ever does.
You're telling me to not play perfectly.
I mean, you can go in, but you have to play perfectly.
Like,
Both
Yeah,
times.
it's hard.
you gotta time your trading. You gotta like make sure like your positioning is pretty good. Like the space between them. If they're moving back, you move back. If they're coming to you, you try to like
That
grab
you
and
probably want to
leave.
save your Q for like any like actual time bomb damage. Because I mean, they all do like little amounts of damage.
Oh, there you
Nice
go.
play.
There you go.
I'm with you. I'm freezing him. Keep putting pressure on him. Never mind.
Oh,
Your team claimed the orb.
oh, that's not
Yeah.
pretty.
Hmm.
I mean, that was good. I mean, that was a bit better. Like,
I'm gonna
they-
put this one on me. I thought you played Pearl.
Round lost.
Someone told me to pick Pearl for you. I assumed that was what you were gonna play.
Oh
I
man,
probably. That's all good.
probably should like taking blocks on
Catchy.
some.
I had no
What's up,
idea.
G?
Yeah.
I play
What's up?
everything, but I'm not good at everything.
I would argue say you can't say you play everything.
Yeah. Like
That's how it is.
I just queue up and then people pick stuff and then I'd be like, oh okay.
That's more like just going with the flow, really. That's alright. Yeah, you're probably gonna play a lot safer.
Yeah, I've been playing for a while though,
But,
so while like in the
I'm in trouble. I need
the
something.
skill part.
Silence.
Yeah,
What the fuck?
don't be too aggressive though. Like
You just have to actually stem them with silence. Yeah. Punish now.
like you can ignore this guy, this melee dude. Like you have to walk to
I'm about
you.
to die.
You can ignore him. Oof.
I don't think you guys can ignore the right.
About 1v1. I mean 1v3
Dude,
discuss.
I thought we were gonna kill the Raygun in the opener. He
Nah.
literally blew all his cooldowns, but the Asmo was free casting you, so something like
Look, Eno, Raygun, Ismo, if he's not like focusing you, ignore him, go for the Uber. Like let's try to kill the Uber.
Yes, sir.
I know you guys are hearing me, and I don't care, but
No, I'm saying yes, sir.
yeah, we about to
I mean, we're losing, but I'm gonna try my best, okay?
yeah.
Sorry.
I mean,
I'm not your caliber.
3, 2, 1, fight.
Yeah, this one's on me. I'm bad.
Alright, we're sending it.
okay.
Enemy team claimed the orb.
Oh, fuck. Oh boy.
That's all she wrote.
Oh damn it.
Then I almost
Wow.
got 210 score. Not quite.
Oh, you frozen.
Okay, are you in the spectator?
I'm watching the thing right now, dude.
Enemy
Are you
team
in the
won
spectator or
orb.
what?
I'm watching Ogre's stream.
Oh, he is streaming?
I'm
Damn,
about to
dude,
die.
why was I captain again? Catch it.
Shit.
Cause you're pretty good at the Freya character.
Yeah.
Yeah, but I can't even play it because
It's okay. Next time you're gonna be a player, okay? And then Tier's gonna be a captain.
Oh, dude, yes, yes. Then I could be like, I'll be dropped.
Play this side,
I'll fall to the second round, and then I'll be like a sleeper, like last pick. You know? Oh, it's gonna be poggers.
What do you mean you're gonna be a pug, like third
Just-
pick? for
Just
sure.
third or fourth pick.
Whoa.
just like Penta's tournament, dude. I was like sixth pick. I can't say it. Sixth.
What up,
Got
bro? I
it.
feel like so mad.
Alright, Pensa's tournament had some a little higher level.
Yeah, it was way higher level.
Yeah, it's crazy.
I think I was captain in the second one because my team like won money in the first one, and then I didn't do as good in that one. Because I had like Gas and then like a really bad player, like I don't remember.
Pretty sure that's like everyone's team.
No, but like he like did the seeds random, and I was like a really high pick, so I got like Gas, but then I had a really bad second pick. But I don't know. I mean, Gas was better than you might remember him, I guess. Or like a lot of people don't, you know what I'm saying. +3, dude. Are you guys streaming or something? Do I have to rally my team?
They were. What the heck?
I'm
It's
trying
supposed to be.
I don't know if there's anyone on now.
I'm gonna add everyone in the DM. I love doing that.
Gotta find Mr. Snow out of me. What's up, bro?
+2, baby. Lupnik's Q up. He might be able to last pick me.
Someone once told me that
Dude,
swords don't kill
last
back.
season I had such a good win rate, and now I'm losing every game. I'm like 1-5. Oh my god.
All you fucking Neanderthals
Yo,
act
are we?
DPS. What the
Are
hell,
you
bro?
scrimming? Yo, Lup. Are
Yo.
you scrimming? I can sub in for someone.
Alright, wait.
Fucking
I'm
trolling,
gonna do
bro.
something.
Yeah, but you're too good. You have to like play a champion you do not play at all.
What?
What are you talking about?
You gotta put Catchy on the. Wait, who's the other person that you're missing? If it's
Baby, I'll replace Baby. It's fine.
oh, okay,
That's
okay.
a captain for a captain there.
Yeah,
Oh,
that's
my captain. Oh,
trade.
captain.
Yeah, I mean, Fabi's is as good at Paloma as anyone is at anything, so I
Yeah.
mean, he's gonna reserve that. I can't get over that statement.
Wait, alright. Do you want to play it then? With
Yeah,
me,
sure. I'm down.
I'll play with Tempest. That's fine with me. Is
That
the
means
draft pod
Ogre's
working right now?
I haven't updated, but it works the same way it did before. Like we have to just like spam
MP the
through
first
the
round?
map draft.
Oh.
Just like
I
the
refuse to
ban
do
stuff.
that. No, we can just do the draft in
It's
typing,
quick, it takes-
like the old days. Okay, it's but you know,
no,
why
because
not?
it has like reserve and oh wait, you have a weird format. Yeah, never mind. We have to do that. I forgot you changed it.
Yeah, can
You
we
like
do?
removed the ban.
Yeah.
Dude, it's easier anyway.
Oh, actually, P is available if you want to scrim
P
them right
said,
now.
yeah.
But
Yeah,
you
then
can play
Catchy can queue up.
Is P on Reborn's team?
Yeah, P's on Reborn.
Yeah, I got DM from him.
Hey, is the bracket?
You have to play right now. You can play.
Hey, Catchy, can you put the bracket out so I can only scrim the teams on the other side of the bracket?
So it's reserve, ban, pick,
Can
ban,
you do that
pick.
for me, Catchy, please? There's no reason, to wait.
RB, PP, BP.
Wait, what?
Isn't your entire team ready though?
Yeah, my
Catchy,
team's ready.
wait, the bracket's just gonna be 1 versus 8 and 2 versus, right? There's no reason, right? So I can
I'll
like.
just random see it. It's fine.
Oh, okay. Well, you should do that so I can see it. You know.
I mean, we'll see at the day on that.
Oh, I gotcha.
But yeah, I'll play with Tempest. I mean, who do you want to play, Love? Like, give me an answer.
Well, I mean, this guy, they got their whole team going. I'd rather
Yeah,
play
go
with
for
them if they don't have a sub.
I just asked Faye if he was here.
Hey, +1 Catchy.
Yo, Ogre's in the queue. Wait, aren't you guys playing right now?
I mean, without our captain being here, kind of just doing it to get the reps in it. Anyway.
Oh, that's true.
See if he shows up.
Just need one. We can get a quick one in real quick. Let's get it.
Ogre, I would have drafted you, but I saw you said prefer melee, so I wanted to give that respect.
We could just do double melee, bro. I just want to have fun, bro. I don't care about the comps.
Yeah, I would have. I promise. The people ahead of me, I don't know why they didn't draft you.
Where was
But
my
me,
team?
I have an excuse.
I don't know. Maybe I'm overrated. Who knows?
I think you're underrated, Ogre. Come on, you
Oh,
go.
bitch.
To go.
He hit
Yeah.
clean that neck on me, though. He's
Just
like,
reserve your Jamila over Favy's Paloma because he's a goat at everything.
Oh, is it?
Ah.
Okay, I'm drafting with P right now.
I just know if he doesn't like losing anymore,
Catchy,
he's
you
without
just
shutting
type
around.
+1 and you're not in queue. That's fucked up.
I'm doing something, buddy.
Yeah, but you're in nail queue. When's your nail
He
queue?
wants to watch
Yeah,
that.
because it's never gonna pop, so I can stay in it forever.
Wow. I digress. Any chance you got the copy paste of all the ads in the Discord, Catchy?
Which one?
In this Discord, so I could like give a go copy paste +1.
Oh, I got you. Hold on. You gotta do the Q trap. That's the secret.
Well,
Yeah, go to
they
general
can't-
info.
they
Catchy
can't-
literally has everyone that's an attorney.
I guess
General
I guess
info,
the-
and yesterday
That
at 9
ain't
o'clock.
cap into that out though.
Okay.
Killing it.
Okay, take this just left, dude. Wait, left. Do you want to play me and Ogre and Tempest?
Who's take this? Why does that matter to me?
He's on Reborn's name.
Oh.
Oh, we about to start. I'll leave the queue. We still have one person.
Do you want to play me if Tigris is not here?
Yeah, sure.
Alright, bet, let's do it.
Are we
How
starting?
are you dropping?
You're dropping the queue.
I was in DMs.
Yeah, okay. So I'm about to jump out this.
Who's my team? Tempest.
Your team claimed the
Your
orb.
boy Gunna. Who is that? Dude.
That boy. That boy gonna. In game. Decent for I don't remember where else he plays now, actually. I know he plays in Ulrich. Oh shit, in game? No. Wait, Catchy, we starting the match.
Wait, I was not. Okay, I'm ready now. 3, 2, 1.
I was just making sure. So I was about to join the queue. They got 5. I was like, I could pop that real quick.
You ready for the Christmas?
Wait, is it banned or pick? What the heck?
It's banned.
Pick me up, whatever. I'm gonna bug my friend.
I don't even. I kind of want to skip the ban. I don't even fucking know.
Who's your team again? You, Oginka? Alright, I got banned.
What does our Tempest play? Let me look at the old general info, player specific info.
Dun, 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 dun.
A lot of functionality that Redis has built in that lets you analyze the data that you're sending in real time. A leaderboard is really cool. Anything that you're voting on things like other and ranking them, Redis has a lot of functionality that it'll work with, such as like a Redis board even. Task queues, cookie storage is something that we've been running into in a recent aspect. You could use Redis for potentially. When you have data that needs to expire after a certain amount of time, when you're doing distributed locks, there's a really great tutorial online about this. If you have any high input-output workflow, such as messaging, and if you've never heard of PubSub, basically it's when you subscribe to something that will broadcast a message, and you broadcast the message to everyone you're subscribed to, not to everyone specifically. So here's a really basic implementation of Redis in Node. It looks a little complicated, but it's really super simple to set up. All you need to do before this would be npm install Redis, which will install Node Redis, which is a Node function for Redis. So basically, we just require Redis into the document, and then you call a create client on it. You'll put in the port you use, the phone name or the IP address, and then basically you just try to authenticate, and then you would put what your database's password would be.
Round lost.
You connect to the client with the client.on connect, and then it'll give you a console when you connect. So then to push something up to Redis, the most basic thing you can do, it would be a client.set operation. So this would just, basically it would set the key foo to the value bar, and then you can do a client get to call bar back and it will console log out bar.
3, 2, 1, fight! Enemy team claimed the orb. Your team won the orb. Your team claimed the orb. The death vortex is incoming. Your team won the orb.
So persistence is probably the most complex thing about Redis.
They are no match for my
Because
skill.
it's completely in memory, it's not really touching the disk very often. It only touches the disk about as much as it needs to. So Redis offers two solutions to persistence. It offers snapshot, which is the most like the default way, and it offers an append-only file or AOF, which is really the main way to persist all of your data. So I'll go through them and talk about their benefits and disadvantages. So
Three,
snapshot is just a
2,
single file, like a
1,
point in time snapshot of your database. So it's really suited well for backups. It's super, super performant. It takes no time, it runs in the background and everything. But what it's not good for is when Redis stops working completely. It needs support very often as well, which will lead to a lot of stuff going on in your background. And when you lose data with snapshot, you can potentially lose data for up to about 5 minutes. It's not always ideal for working on building super huge data. So your append-only file is a big parsable log file, and you have a bunch of different sync policies you can do, so it's a lot more controlled than snapshot is when you look at how your disk is actually persisting. You can control a bit more with the read and write functions. There's no seed for corruption, so it's really good for power outages. It automatically rewrites itself when it gets too big for the disk, which is awesome. It's a much larger file, meaning it's slower, it's buggier, it's very, very easy. But the big benefit is that on the worst case, you'll lose data for about 2 seconds, which is really great. So we have these two worlds, and you kind of say, do I want the really secure database that's always there, or want the really portable database that's a lot lighter to run? And the answer to that is why don't we have that? Most times when you're implementing a database, you're going to use both systems to persist your data. So it's a little bit more complex than SQL in persisting, but it's very, very stable if you want to use it as your primary data source and use it. So if you want to learn more about Redis, you should look at redis.io. That is the main website. There is a tutorial up there to get the basic commands. It's super easy. And then redislabs.com has a whole bunch of tutorials that will teach you very specific things that you want to do, including if you're doing new blocks or syncing up to a specific thing like socket.io or Node, it's probably there. It's a great community.
Your team claimed
really,
the
really
orb.
fun to play with.
Star, I have failed you.
Victory.
This spear is as sharp sharp as the day I bought it.
Thanks for President Trump. Oh my God.
Hi everyone. This video we'll be talking about what caching is and how we can use it to design systems. So at the end of this video, you should be able to tell what a cache is and the situations where a cache can be used, and of course, how you'll be using it. So what is a cache? Imagine you have this server and you have a database from which you pull out results. So whenever there's a user request to your server, you actually pull out results from the database. There are two scenarios where you might want to use a cache. The first use case is when you're querying for some commonly used data. For example, you have your profile and that is stored in this database. The same user is asking for the profile multiple times, and had you saved it in this box, then you would have saved a lot of computation. So within this box, maybe you can keep a cache, an in-memory cache, which is in your memory. It stores the profile per user, so you have a key and a value. And so that is the first reason why you want a cache, to save network calls. The second use case is when you want to be avoiding computations. For example, you want to find the average of all users, the average age of all users that you have in your system. In this case, one of the ways that you can do this is every time a person asks you for the average age, you go to the database, get all the users, find the average of the age, and then return that. Now, this is very expensive, of course. So instead, what you can do is you can do this once, find the average age, and then store it in the cache. So that's a key and a value. So average, and then 26, 28, whatever be the thing, it's a key value, store it in cache. The final scenario where you want to be using a cache is when you want to avoid load on the database. So if you have a lot of servers and they're all hitting the database to get information, it's going to be putting a lot of load. Instead, you can get some caches, maybe 2 or 3, distributed system, after all, and then you can keep that information in the cache. You can hit the caches, avoid hitting the database. But the first 2 points are the key ideas of a cache, which is either avoiding a network call or avoiding computations. And both of them are designed to help you speed up responses to your clients. So a client makes a call and you immediately give a response if you have it in cache instead of making a query to the database. So now that you know the benefits of a cache, your first instinct might be to just store everything in the cache, like cram it up with all the information, because the response times are much faster when you're going data from the cache. You can't do that for multiple reasons. Firstly, the hardware on which a cache runs is usually much more expensive than that of a normal database. The reason being that this cache usually runs on SSDs, which are expensive compared to commodity hardware that a database runs on. The second thing is that if you store a ton of data in the cache, then the search times will increase. And as the search times keep on increasing, it makes less and lesser sense to use the cache. Why don't you just go and hit the database? Yeah. So you'll be saving on the network call, yes, but a ton of data on the cache is not just expensive, but also counterproductive. So our problem becomes storing information in cache such that the database has almost infinite information, while the cache needs to have the most relevant information according to the requests which are going to come in future. So we need to predict something. To predict things, we need to ask ourselves just 2 important questions. When do I make an entry in the cache, which is when do I load data into the cache, and when do I evict data out of the cache? The way in which you decide for loading or evicting data is called a policy. Because this video is on caching, this is called a cache policy. So your cache performance almost entirely depends on your cache policy. There's multiple policies you can have. LRU is probably the most popular. It's recently used. What this says is that whenever you're pulling in entries to the cache, keep it on the top, and whenever you need to kick out people, kick out the bottommost entries, which means the least recently used entries in the cache. So the top entries are going to be maybe seconds ago, very few seconds ago, and then you keep going down the list, minutes ago, hours ago, years ago, and then you pick out the last entries when you do need to. Okay, for example, if there's a celebrity who's made a post, made a comment, and everyone wants to pull that comment, so you keep that on top of the cache, and while it is hot, while everyone wants to use that comment, it gets on top of the cache, it's performing really well, and when it gets cooler, when people stop asking for that comment, it keeps getting pushed to the end of the cache, and then it's kicked out. Alright, so that's the LRU policy. The LFU policy is frequently used, is not frequently used in the real world, so you can read on it, of course, and some policies have started to perform really good, I mean even better than LRU. So they are sliding window based policies. one of the Google developers who made caffeine has implemented this in the caches. Now imagine you have a really poor eviction policy, which means that hitting the cache is of no use. And if you ask the cache for some data, it always responds with, I don't have it. And then you have to go to the database again. The first problem over here, which is with the poor eviction policy, is that it's actually harmful to have a cache because you are making that call, that extra call, which is completely useless if you have a poor eviction policy. So the second problem can occur if you have a very small cache. So users X and Y need their profiles, and this is a profile cache. So X asks for their profile, you get it from the database, you put X in this cache, and let's say it can just store one entry. Y asks for their profile, you have a cache miss, you go and hit the database, get that entry, populate it in the cache, and now X makes another call, which means they need X. So there's a problem here. So this concept is called crashing.
At this moment on Wall Street, the market is experiencing the most volatile trading in over a century.
Market's down 1,000 points. I hear the exchange is a total mess.
Your orders being acknowledged? I hope so. I've got 4 people on while other systems were stalling during one of the most volatile days.
I got confirmation.
Trading systems built on the InterSystems data platform.
The order's been acknowledged.
Operating as usual. Chaos out there. Not so bad here, though. For stability in an unpredictable world, look to InterSystems. Does your private ever use a teleprompter during local interviews or to answer Q&As?
What will your administration do to help them give them that chance?
Round one.
You're constantly
There's nothing
inputting
like
and outputting into the cache without ever using the results. So it's again hurting you more than helping you. The final and most important problem, I'm sure you guys have already realized, is that what about consistency? So if a different server makes a call to the database for an update and says update profile X, yeah, so there's an update over here, but the cache doesn't have that entry updated. So server 1 pulls from the cache, gets the user profile for X outdated profile, and then serves it back. So maybe the user has changed their password, and you have the old entry, the old password is still working, maybe there's a hacker who actually hacked the old password. This becomes an issue of data consistency. Now let's try to figure out where to place the cache. The cache can be placed close to the database, or it can be placed close to the server. There's benefits for both and drawbacks for both. If you place the cache close to the servers, how close can you place it? You can place it in memory itself, yeah? So you can put the cache in memory in the server. If you do this, what's going to happen is that the amount of memory in your server is going to be used up by your cache. But if the number of results that you're working with is really small and you need to save on these network calls, then you can just keep it in memory. A few other things over here are that what if this server fails? If it fails, then this in-memory cache also fails, and we need to take care of that.
There's
The second
nothing
thing
like
is,
art
what if
that
this
touches
data
your
over here on
heart.
S1 and this data on S2 are not consistent? So they are not in sync. In that case, it depends on your application. If it is a user profile, it's really not that big a deal. But if it's passwords, if it's financial information, if it's something critical, critical data, then you can't keep this. So benefits of actually having closer to the server is that it's faster here. And it's also rather simpler to implement. But the benefits of having it separate are going to be seen now. You can have something like a global cache.
I've tried eating this. I am the hammer of righteousness.
It is always a good time.
I'll show them all of my tricks, and none will be the wiser.
The benefit of this is that all servers are hitting this global cache. It's limited in size, so if there's a miss, it's going to be querying the database. Otherwise, it's going to be returning. What's the possible benefit? Well, you're avoiding queries on the database and increasing queries on the cache. But more than anything, actually, this is faster discrete. So it's going to be something like Redis. I think a lot of people are actually asking me what this is.
Oh, I'm leaving this queue for now.
Use cases of Redis. It's like
and I'm probably gonna
storage,
log
which is
out
like a cache.
after this.
So this is a cache. Basically, you can keep a few boxes which are just going to be storing memory, and whenever a person asks for a key, you return a value. In this case, what happens if S2 crashes? Nothing really, because everyone is going to be querying this global cache anyway. And because it is distributed and it's going to be maintaining that data consistency, we can offload all that information, all that headache to this guy over here. Although it is slightly slower, it's more accurate. In in this choice range of placing the cache, I would rather place it somewhere over here as a global cache. The main reason for this is there's higher accuracy in the sense that if a server crashes, it doesn't take its data to its grave. Yeah, it's more resilient in that way. The second reason is that you can scale this independently. Yeah, you can scale the Redis caches independently while keeping the services as containers running on these boxes. So there are certain boxes which are just running services which don't have their data being eaten up by a cache. So my preference would be a global cache. However, for simplicity and for extremely fast response times, you can keep it in the local memory. We are now onto the final important characteristic of a cache, which decides how consistent the data in this is, and that is whether it's a write through or a write back cache. A write through cache means that when you need to make an update to the data that you have, let's say you're making an update to the profile X, you hit the cache, you see that there is profile X in this, and so there is going to be some data inconsistency if you make an update directly to the database. Remember that person X has changed their password. So I'll make an update to the entry for user X, make that update, and then push it to the database. So that's a write through cache. I wrote on the cache before going through it and hitting the database. The second option, of course, is to hit the database directly. And once you have hit the database, make sure to make an entry in the cache. So either the database can tell the cache that this entry is no longer valid, or you hit the cache, you see that there's an entry for X, just kick it out, evict it, delete that entry. Once it's deleted, update the database. When there will be a query on the cache, it's going to come here, it's going to see that X does not exist, and so it's going to pull from the database and then send it back to you. Okay, so this is the write-through mechanism. I mean, the original one where you hit the cache, make the update, and then send it to the database. And the write-back is where you hit the database and then make sure that the cache is having a null entry. What is a possible problem in the write-through cache? Well, you do the write over here, you go and write it on a database, but what if there are other servers having this cache in memory? Yeah, the profile entry for X is on S1, and the profile entry for X is also on S2. So this is an in-memory cache, and you're doing a write-through, so you actually update this entry, but what about these guys? So in that case, basically your write-through is a little silly, so you can't implement this algorithm, you have to go for write-back. However, there's one issue in the write-back, and that is performance. When you update the store, the real store, the one source of truth that you have, and you keep updating the cache based on that, what's going to happen is there's going to be lots of entries in the cache which are fine. I mean, your consistency is not so important. So invalidating them is going to be expensive because whenever there's a request, you have to send a response from the database and then update the cache. So this is like the thrashing thing that we have again. So write-back is expensive. How can we do better? As usual, just use a hybrid sort of mechanism. Write-through and write-back are both giving you advantages and disadvantages. What you can do is, whenever there's an entry that has to be updated on the database, don't write back immediately. Write onto the cache if it's not a critical entry. If it's something like the person has their comment changed, edited, just write onto the cache, keep serving requests through this box, and when, I mean, there might be data inconsistency, but you really care. 10 seconds have passed, 20 seconds have passed, and when you have actually seen that there is some scope for you to persist entries, take entries in bulk and persist it onto the database. So that's one network call, and you are saving on hitting the database consistently. So what we can do is, instead of taking one core policy, we take a hybrid, and then we take the best of both worlds. Depending on your scenario, if this is financial data, if this is passwords, you can't have write-through cache. You need a write-back cache. But if it's not critical data, then you can go for saving network calls this way. So caching is extensively used in system design. One very good online course for system design is Grokking the System Design Interview. I have a link in the description below, and of course I'll explain to you what it is. This is a part of the set of courses that educative.io offers. Grokking the System Design Interview is a very famous course. A lot of people before their system design interviews, they go through this course in detail. The best thing about this is that it has a lot of topics when it comes to load balancing or caching, so on and so forth. It's got a lot of those simple topics, and it's got a lot of systems that it has actually designed. So with this, you get hands-on experience on designing systems. So that's it for what caching is and what are its use cases. You can use it in system design extensively. It's actually used in real-world systems. So if you have any doubts or suggestions on this, of course, you can leave them in the comments below. And if you like the video, then make sure to hit the like button. And if you want notifications for further videos like this, hit the subscribe button. I'll see you next time.
Your team won the orb.
Hi, and welcome to the System Design Iteration. Today, we design a distributed cache. We will start with some simple ideas, and little by little, evolve our design into a fully fledged architecture. Approach that we highly encourage you to use during a real interview. We also will discuss several important tips along the way. As usual, let's start with the problem statement. Let's take a look at a typical setup. A web application backed by a data store. This data store may be a database or another web service. Client makes a call to the web application, which in turn makes a call to the data store, and the result is returned back to the client. There may be several issues with this setup. First, calls to the data store may take a long time to execute, or may utilize a lot of system resources. It would be good to store at least some results of these calls in memory, so that these results are retrieved and returned back to the client much faster. And if the data store is down or experiences a performance degradation, and calls to the data store start to fail, our web application may still process requests as usual, at least for some period of time. So, storing data in memory will help to address these issues. When client request comes, we first check the cache and try to retrieve information from memory. And only if data is unavailable or stale, we then make a call to the data store. And why do we call it a distributed cache? Because the amount of data is too large to be stored in memory of a single machine. And we need to split the data and store it across several machines. Caches are everywhere nowadays, even on this channel. Remember when we designed distributed message queue, or notification service, or rate limiter? All those designs relied on a cache of some sort. Let's formalize requirements. We need to implement two main operations, put and get. Put stores object in the cache under some unique key, and get retrieves object from the cache based on the key. To simplify things a bit, let's consider both key and value to be strict. As for non-functional requirements, we want to design a scalable, highly available, and fast cache. High scalability will help to ensure our cache can handle increased number of put and get requests, and be able to handle increasing amount of data we may need to store in the cache. High availability will help to ensure that data in the cache is not lost during hardware failures, and cache is accessible in case of network partitions. This will minimize number of cache misses and as a result number of calls to the data store. And high performance is probably the number one requirement for the cache. The whole point of the cache is to be fast, as it is called on every request. And here is the tip. During an interview, when we need to define requirements, it's relatively easy to come up with functional requirements, or a set of operations system will support. These are 1, 2, 3 operations which clearly characterize the system. Usually something around sending data to the system and retrieving it, right? But non-functional requirements may not be easy to define. What do we do? If you need to design a distributed system, think about the following 3 requirements first: scalability, availability, and performance. And if data persistence is important, think of durability as well. This 4 will give you and your interviewer a lot of room for discussion. If you recollect a CAP theory, availability requirement may be replaced with consistency. But let me keep it simple for now, and not dive deep into this topic here. I will elaborate more on this in a separate video. And here is my second tip. Remember that interviewer is your friend, and you both have the same goal. Your goal is to provide as many positive data points as possible. And the interviewer's goal is to collect as many data points as possible. In practice, it means that you should start approaching any design problem with some small and simple steps, and evolve your solution with every next step. This is a win-win situation. You demonstrate progress, ability to deal with ambiguity and simplify things. While the interviewer gets all the necessary data points to bring them to the table and champion your case in the discussion with other interviewers from the interview. With this in mind, let's start with the local cache first. You will later see how distributed cache design evolves from the solution for the local cache. So, we start with a single server and need to implement a basic in-memory data store that has limited capacity. Local cache implementation is an algorithmic problem. We need to come up with data structures and an algorithm for storing and retrieving data. What data structure comes to your mind when you hear about cache? Most likely the same that comes to my mind, which is a hash table. We add key-value pairs to the hash table and retrieve them in constant time. Simple, right? But only until the moment when we reach maximum hash table size and cannot add any more elements. We need to evict some old data from the hash table before new data can be added. What data should be evicted? It turns out there are several dozens of different approaches, so-called eviction or replacement policies. One of the easiest to implement is the least recently used policy, when we discard the least recently used items first. But hash tables do not track which entry has been used recently, meaning that we need one more data structure to keep track of what was used when. Some kind of a queue, but with a constant time for add, update, and delete operations.
Okay,
And
this is probably my last match. I gotta
no. And I have no other choice than to agree with
work on my game.
By the way, least recently used cache implementation is a very popular coding interview question. It's marked as a hard problem on the lead code. But you will see that it's relatively easy to implement once you know what data structures to use. When get operation is called, we first check if this item is in the cache, hash table. If item is not in the cache, we return null immediately. If item is found, we need to move it to the head of the list and return the item back to the column. And why do we need to move the item to the list head? To preserve the order of use. Item at the head of the list is the most recently used, and item at the tail of the list is the least recently used. So, when cache is full and we need to free space for a new item, we remove an item at the tail of the list. When put operation.
My name is Suraj. I'm Praful, and we are here to represent India's largest gaming company, Play Games 24/7. And we wanted to share all the pains, all the challenges that we have faced in building a highly concurrent, low latency gaming platform. Our agenda is very simple. We'll first talk about who we are, what we represent. Second, we'll talk about one of our recent products in which we faced a lot of issues and challenges. In third, we'll talk about those challenges. We'll see how Redis helped us solve these problems. So, who we are? We are Play Games 24/7, India's largest gaming company. We have got two distinguished products. The first one being Rummy Circle. It's an online card-based rummy platform. It is very popular in India. The second product is My 11 Circle. It's a cricket-based fantasy platform. People come a lot on this platform. This was launched this year, January. We are a pure data-driven company. Every feature, every decision that we take is backed by solid data analysis. And in order to do this solid data capture, analysis, campaigning, we have also created our in-house platform to collect this data, run campaigns, and analyze them. We are all on AWS now, and we use their services heavily. Now on, we'll talk about our product, which is My 11 Server. So it's a cricket-based fantasy platform. We launched this year, January, and what we saw was there was a huge amount of growth in the user base after we launched. And what we're expecting is that in the next few months, our user base will grow 5 times of what we have right now. So this is a clear sign that we have to prepare our platform, we have to build our platform so that it can scale with should be fault tolerant, and a low latency is a must.
Now here we have used two words. One is cricket and another is fantasy. How many of you know cricket, by the way? Oh, fair amount. Okay, so I would briefly tell you what is cricket. So cricket, like any other game, is a game which is played between two teams. They compete against each other to win. And it's more like baseball, where one team is batting and the other one is fielding first. So the team who is batting tries to score as many runs as possible in a given over range, and after that the team who was fielding first tries to chase those many runs, and the team who scores most wins.
The way Indian.
Now let me
No,
talk about
the way
what is fantasy gaming. So actually in cricket you
Is
have
it
actual
Indian?
players playing on the field. A game is going on in a live cricket stadium, and
The way
you
Indian
are sitting
people speak is
on
so
a corner
funny.
of your house, and you want to also participate in that game. So what do? You create your own fantasy
Yes, we
virtual
forfeited.
team out of favorite players across the teams playing, and then
Alright, guys,
that
I'm gonna
makes
end the
your
match,
team. And
the
what do you
stream
do with
here.
that team?
Thanks for watching.
So that team, with
Peace
that
out.
team, you